The electronic transition responsible for the color of the transition metal ion is. The options are shown here. This is the 5 D orbitals of the transition metal ion. These orbitals are dx square minus y square, dz square, dxy, dyz and dzx. Now we see the shapes of these 5 d orbitals of the transition metal ion. First we see the dxy. To simplify this picture, we remove the z-axis. Here the lobes of the d orbitals lies in between the x and y axis. Next we see the dyz orbital. So we remove the x-axis. Here the lobes of the d orbitals lies in between y and z axis. The next one is dxz orbital. So we remove the y axis. Here the lobes of the d orbitals lies in between the x and z axis. The fourth one is dx square minus y square. Here we remove the z axis. In this orbital, the lobes of the d orbitals lies along the x and y axis, not in between the axis. In similar way, the dz square orbitals lies along the z axis. The dxy, dyz, dxz symmetry is labeled as T2G. The dx square minus y square and dz square symmetry is labeled as EG. The dxy, dyz and dxz orbitals can overlap with the pi orbitals of the ligands on sideways. So these orbitals are called as pi orbitals. The EG orbitals can overlap with the ligands of the orbitals by linear way, so it can say sigma orbitals. Here the T2G orbitals are pi orbitals because it can form pi bonds with the ligands. The EG orbitals are said to be sigma orbitals because it can form sigma bond with the ligand orbitals. When the 6 ligands orbitals are approaching the central metal ion, its energy is increases. Because according to CFT, the bonding between the metal cation and the ligand arises from the electrostatic attraction between the nucleus of the metal cation and partial negative charge present on the ligand. The interaction between the electrons of the cation and those of the ligand is entirely repulsive. The repulsive forces are responsible for causing the splitting of d orbitals. These repulsive forces increase the energy. Now these d orbitals are split into T2G and EG orbital with the different energies. Why these orbitals having different energies? Now we see the reason. The T2G orbitals lies in between the axis. The ligands will be lies along the axis. So the repulsive force is very less in T2G orbital. So it energy is decreases. Whereas the EG orbitals are lies along the axis. So the repulsive force between the central metal cation and the ligands orbitals are very high. So its energy is increases because both the orbital lobes are along the axis. Here we have to find out the which is correct electronic transition. The transition metal ion of the color is may due to DD transition or charge transfer transition. Here it is given as DD transition. We have to find out the correct orbital transition. So let me take the example of hexa-aqua titanium 3 complex ion. Here it has a D1 configuration. On irradiation, the electron is transferred from T2G orbital to EG orbital. We get DD transition, or otherwise we can say d pi to d sigma. So the electronic transition responsible for the color of the transition metal ion is d pi to d sigma. That is the first option is the correct answer. Thank you.